Hello there, this is Professor Eckhouse, and I'm going to talk about simplifying and using square roots. So we're going to start with simplifying expressions with squares and square roots, but first I'd like to show you just a visual. If you look at 2 squared, which is this one, that means we have 2 and 2 on the 2 sides of the square, and that's where the word squared comes from. And so if we have 2 by 2, we have 1, 2, 3, 4 square ones, right? So there's 4. So 2 times 2 is 4. 3 times 3, 3 squared, is 9, and so on. Okay, so the square of a number is shown like in the first gray box there. And a perfect square is a square of a whole number. That's considered a perfect square. Okay, so all of these are perfect squares. 4 is a perfect square, 9, 16, 25, 6 squared is 36, 7 squared is 49. All right, so what happens if you square a negative number? So let's talk about these. Negative 6 squared means negative 6 times negative 6. So it's always going to become positive. So what about the next one? Well, this one is different. This negative is not on the inside. We're not squaring a negative 6. We're squaring a 6, and it's negative on the outside. So we've got negative 6 times 6, which is negative 36. This means the same thing as that. When there is a 2 in the exponent, or a 3 or a 4, it's only applying to the thing it's sitting next to. And if there are no parentheses, it's only applied to the 6. So this one is the same as the one up above, like that. Negative 6 times 6 is just negative 36. So be careful. Parentheses really do make a big difference with squares. Okay, so square roots. A number whose square is m is called a square root of m. So if n squared is m, then n is a square root of m. In other words, if 3 squared is 9, then 3 is the square root of 9. Okay? So since 9 squared is 81, and negative 9 squared is 81, then technically the square root of 81 could be 9, or it could be negative 9. The positive answer is what we call the principal root, or the principal square root. And we're just going to be using the principal roots in this class. Okay. All right, so square root of m is read as square root of m. If m equals n squared, then the square root of m equals n. That's the definition of square root. Okay, so some things you need to know are the radical sign. The radical sign is the outside part, and the radicand is the thing on the inside. So know those 2 words. Something else that's helpful is a multiplication chart. So I always recommend that my students have a multiplication chart in front of them to do work instead of reaching for the calculator for doing basic things, because the visual of this will start to kind of sink in, and it'll help you to remember. But take a look at what I've got highlighted in yellow. Those are the perfect squares. So 1 squared, 2 squared, 3 squared, 4 squared. So those numbers you need to memorize. You really need to know the perfect squares up to at least 144, if not all the way to 225. All right, so you should be done working on your multiplication facts by now, so you should have them memorized. If not, you need to know them as soon as possible. So here they are, listed just as the square roots and the perfect squares. All right, so simplify square root of 25. So this is the kind of problem you're going to have. You shouldn't have to use a calculator on these. So there will be a portion on the final where you have to know these without a calculator. So really, really do try to memorize these. So the square root of 25 is 5, and the square root of 121 is 11, and I would recommend going and finding some flashcards or something if you still don't have these memorized. All right, so is there a difference between negative square root of 9 and square root of negative 9? Yes, there is, definitely. This one, we are not taking the square root of the 9, and this one we're trying to take the square root of a negative number. All right? So there is a big difference. So I'm going to talk about it more in just a moment, but think about these 2 right here. So A says the negative of the square root of 9. So we're going to do the square root of 9 and take its negative. Okay, so that means negative 3. All right, b is negative of the square root of 144. It is not the square root of negative 144. The negative is on the outside. So the negative stays on the outside, and we take the square root of 144 is 12. All right, so can we take the square root of a negative number? And why not? The answer is no. No, we cannot. But why not? So is there a number that when we square it in here, it appears twice and equals negative 25? Is there a number that multiplied by itself can be negative? If you can think of something, please tell me, because I don't know of any numbers that can do that until we get into imaginary numbers, and that's a different thing, so in a much higher math. So we're not going to worry about that, but there's not a number, a real number, that we can square and get negative 25. All right, so let's simplify A, the square root of negative 169, versus B, the square root of negative 121. So try that. All right, so A, hopefully you found that there's no solution. There's no solution to that. We can't take the square root of a negative number. But the next one, we've got the negative is on the outside. So we're just going to keep the negative on the outside. And what is the square root of 121? Well, that's 11. So the answer is negative 11. So be careful. It makes a huge difference. All right, so estimating a square root that is not a perfect square. So estimating a square root that is not a perfect square. So I want you to keep in mind that the square root of 4 is less than the square root of 5, which is less than the square root of 6, which is less than the square root of 7, which is less than the square root of 8, which is less than the square root of 9. Well, the square root of 4 is 2, and the square root of 9 is 3. So that means the square root of 5, 6, 7, and 8 must lie between 2 and 3. It has to be between 2 and 3. And if you take a calculator and find the square root of 5, it will be close to 2, but bigger. Square root of 6 is a little bigger, still between 2 and 3. Square root of 7, a little bigger, between 2 and 3. Okay, so that is estimating. All right, so let's estimate square root of 60 between two consecutive whole numbers. So what is the square root? Without a calculator, estimate square root of 60. All right, so the 6 squared is 36, 7 squared is 49, 8 squared is 64, and this is where having them handy in your head really makes things easier. So 60 lies right in here, close to 64. Okay, so 60 is here between 49 and 64, closer to 64, which means square root of 60 is going to lie between 7 and 8, probably closer to 8. And if you do it on your calculator, you will find that the square root of 60, so we're going to say the estimation is maybe, I don't know, 7.7? 7.8 maybe? Something like that, close to 8. And if you look at your calculator, it's 7.75. Okay, ish. I think I rounded it. Okay, so approximating square root. So approximating with a calculator. Approximating is because we say approximating because we're going to have to round because these are irrational numbers generally. All right, so first find the square root symbol on your calculator, and that is going to be right there. Oh, that didn't show up very well. Right there, which means we're going to have to use the second button and that. Oh, no, actually, that's the any square root. Sorry. So that's any roots. That's if you're trying to find the third root. We're not going to do that. So we are looking at this one right here. Gosh, sorry about that. And we're going to hit the second to get to that. So we'll hit second and square. So they put them on the same button, square and square root. That's how I caught my mistake. I saw the little up arrow. I was like, wait a minute. Okay, so that's the square root symbol on your calculator. So square roots are usually irrational numbers, which means we have to round the answer. So pay attention to what is asked for in the problem. So when you hit the second and the x squared button, you're going to get a radical sign, and there's going to be a little box, and that's where you're going to put your number. Okay, so you can put more than that in there if you want to, more than just one number, but like if you want to add something or multiply something on the inside there, you can actually fit all that in there. It acts like a parenthesis. All right, so try all of those and see what you get. You're supposed to round to 2 decimal places in this particular problem. All right, so for square root of 17, you should have gotten 4.1231 and so on. And that is going to round. Now it says to 2 decimal places. That's to this one right here. So what is the 3 going to do to the 2? Well, it's not going to round it up. It's going to keep it at 2, 4.12. Square root of 54, you should get 7.3484 and so on. There's more numbers there, but I don't need them because I'm rounding again to the 2 decimal places, the hundredths place. So that's going to, what is the 8 going to do to the 4? What's that going to do to the 4? It's going to make it a 5, so I get 7.35. And the last one, square root of 21, is 4.58257 and so on. And again, we're going to round to the hundredths place, 2 decimal places. So what is the 2 going to do to the 8? It's not going to round it up, so this stays 4.58. Okay, and I use the approximation because we are estimating, right? We're approximating, so we use the squiggly equal sign. Okay, so simplify expressions with square roots using order of operation. These are very important. People mess these up all the time. So we've got the square root of 25 plus the square root of 144, right? So the square root of 25 plus the square root of 144. That's A. So the square root of 25, these act like parentheses, so be careful. The radical sign is a grouping symbol, so you really need to pay attention and do what's under each one separately. So it's a grouping symbol. This is 5 plus 12, so we get 17. So I'd like you to contrast this to the square root of 25 plus 144. So this is a grouping symbol here. So we've got to do everything on the inside first. So add first. Do not take the square root of 25 and the square root of 144 and add them together, because that gives us 17. This is going to give us the square root of 169. Well, what's the square root of 169? That's 13. Very different. So be careful. You've got to use the grouping symbol of the radical sign carefully. All right, next one. So try another version of this problem. This is from the book. So there's some great problems in the book and great videos. Hopefully you've been trying those. So simplify square root of 49 plus square root of 64. Square root of 49 is 7. Square root of 64 is 8. So you should get 15 on this one. The next one, the square root of 9 plus 16, well, you've got to keep this together and do what's inside first, and you get the square root of 25. The square root of 25 is 5, so your answer is 5. All right, so contrast that to the square root of 9 plus the square root of 16. So that's going to be 3 plus 4 is 7. That's a different answer, okay? So that is not what it's asking for. Okay, simplify variable expressions with square roots. So just a reminder, the square root of 9 is the square root of 3 squared, right, which is 3. So keep that in mind. So what is the square root then of x squared? So the square root of x squared is just x. That is a very important concept for what we're about to do. Okay, so simplify square root of 16x squared. All right, so square root of 16x squared. So think of this as 4 squared times x squared underneath there. So the square root of 4 squared times x squared is going to just be 4x. All right, so next one, simplify square root of 81y squared. So the negative stays on the outside and you can just ignore it. And square root of 89 is like square root of 9 squared times y squared. So the negative stays on the outside. The square root of 9 squared is 9. The square root of y squared is y. So negative 9y. All right, why don't you give this one a try? All right, so hopefully you thought 36 is 6 squared. X is x squared. Y is y squared. So this becomes 6xy. The square root of 6 squared is 6. The square root of x squared is x, and so on. All right, using square roots in applications. Identify what you're asked to find, write a phrase that gives the information to find it, translate. This is the same thing we've been doing, but we're doing it with square roots now. All right, so square roots in area. Mike and Michelle want to make a square patio. They have enough concrete for an area of 200 square feet. So to the nearest tenth of a foot, how long can a side be? Well, remember, a square is area is s squared. All right, so we were just going to have to take the square root of 200. So the area, the side is going to be the square root of s squared, right? Square root of s squared. That will give it to us. So we've got 200, which is s squared. So the square root of that, what is the square root of 200? I'm going to have to use my calculator for that because I realized I did not put this on a key. 200 square root is 14.1421 and so on. It says to the nearest tenth of a foot. So the tenth of a foot is right there, and we get 14.1 feet. All right, so that's going to be the side. And you can double check by taking 14.1 times 14.1 because that's going to be the square, the side of the square. And it will be close to 200 because we rounded. All right, so square roots in gravity. If something is dropped from h feet above the ground, you can find out how long it's going to take to reach the ground by using this formula right here, square root of h over 4. That's kind of cool. So Christy dropped her sunglasses from a bridge 400 feet above a river. How many seconds does it take for the sunglasses to reach the river? Well, this is h, the height of the river. So we're going to say the square root of 400 divided by 4. So first you're going to say the square root of 400, and that is going to be 20. Divide that by 4, and you get 5. So that says how many seconds? So 5 seconds. It's going to take 5 seconds for it to reach the river. So she can probably count, sadly, as it falls to the river. All right. So square roots in car accidents. There's a formula for a particular kind of tire and car and all that. If the length of a skid mark is d feet, then the speed of the car can be found. So you always wonder maybe how they figured out how fast a car was going in an accident. They look at the skid marks. So square root of 24 times the distance of the skid mark will tell you how fast the car was going. And it's in miles per hour. So if you were looking at another unit, this would not work. All right, so after a car accident, the skid marks for one car measured 190 feet. So that is D. D equals 190 feet. Those are the skid marks. To the nearest tenth, what was the speed of the car? So we just said that the speed is found with this formula right here. So speed is going to be the square root of 24 times D, which is the square root of 24 times 190. So 190 times 24, you can hear me doing on my calculator, is the square root of 4560. So we're going to take the square root of that answer, and we get 67.52777 and so on. So it says to the nearest tenth. So the tenth would be that one right there. So what is the 2 going to do to the 5? Nothing. So it's going to leave it a 5. So this is going to be that the speed of the car was 67.5, and it says in miles per hour. So we'll say miles per hour. Okay, I believe that's my last one. Thank you for watching.